Hi and welcome to Java 3D Maze presentation. The authors are Gabay and Ilan Latam. First of all, let's take a look in our architecture design. Our program architecture is implements by server side and client side. The client send a request to the server with serialized Java's objects, the server is solve the request and send a response with serialized Java's object that implements the result. If there is an error, then the server send an error message. In addition, the server save cache data at local SQL database. The cache data can be contain generated mazes and solutions for this mazes. The main functionals of our project are: generate new maze with custom properties, generate solution for each maze, save the mazes and solutions at database, load mazes and solutions from database, get a hint, go to goal position, export maze to file, import maze from file. For solving the maze, the server's model use two search algorithms. The first is BFS and the second one is DFS. Now let's see the game in action. First we going to run an instance of the server. After the server is start listen to clients, we going to run two clients in parallel. For example, we create a new maze in the right game and load the same maze from the left window. After we load the maze, we can ask for hint or create a solution. The solution for the maze is save in cache. If we load the same maze at the right window and ask for the server to solve the maze, we are getting an error message said that the solution is already created, so let's just load it. If we tired from try to solve the maze, we can just ask from the player to go the goal position. After we done to play the maze, we are going to close all the windows and see that all the processes are shut down without any error message and there is no any processor thread that's still running. The client side is implements by MVP architectural pattern. The view object give the user the ability to play the maze with graphical or command user interface. When the user action the interface, then the view is notify the presenter. The presenter is called to the right function at the model, and after this function is done to run, the model notify the presenter with the output of the function, and then the presenter run the right function at the view. The separation of layer is opening for us the possibility to maintain each side of the objects independently. Now let's review the server-side implementation. Our servers using MVC as architectural pattern for handling client requests and server's graphical user interface commands. MVC architectural pattern is include three parts. In the one side we have the graphical user interface that give the user the ability to follow server's log and manage clients. On the other side we have the model that responsible to do the requests from the clients or commands from the user, and in the middle we have the controller that connect both sides. Here is the part the handling client socket and send it to the model part. And here is the model part that actually run the core functions of the game like generate and solve mazes. In addition, there is some more features that our project is include, like the possibility to do zoom in and zoom out by holding control key and play with the mouse's wheel. We have the ability to load the properties of the server and the client from XML file, and we using graphical interface at the server side to manage sockets. Thanks for watching the video and hope that you enjoyed.